Hello, episode 2, welcome, Gauss Grade 8, 2023, and we'll talk about 4 problems in this episode. Start with problem number 18. Of course, you cannot see problems here because I'm doing all work on paper. And before I talk about the solution, I will briefly describe every problem. I will tell you what the problem is talking about and what problem is asking for. But I strongly encourage you to go to the official website of Waterloo Contests by yourself and see the original paper. And I would encourage you to do the problems or to try to do the problems before you look at my solution. Okay. So anyway, let's have a look at the problem number 18. It says the product of a pair of 2-digit positive integers is 630. Basically, we've got a pair x and y, and x times y, that's the product, is 630. And there's one restriction. Both numbers are 2-digit numbers. Okay, 2-digit numbers. And the question asks for the total number of pairs out there. So, for example, 63 times 10 is a pair. And what about 10 times 63? Okay, in this problem, the order doesn't matter because it only asks for the total number of pairs. So 63 and 10 and 10, 63 will be considered 1 as opposed to 2. Okay, let's be clear about that. Then, of course, we can name a few like 63 times 10, but how can we make sure that we are not missing anything? So we need to first factor 630 to get a general idea of what is going on here. It is 10 times 63, which goes to 2 times 5 times 3 to the power of 2 or 3 squared times 7. Okay, and based on that, we will understand that the total number of factors of 630 is 1 plus 1 times 1 plus 1 times 2 plus 1 times 1 plus 1. What's that? 2, 2, 2, 8. Okay, that is 24. That is 24. Meaning 630 has a total of 24 factors. Or we can say it has, we can get a total of 12. That's half of 24. We can get a total of 12 pairs, no matter if these numbers are 2 digits or not. And let's try to list them out. The first pair would be 1 times something is 630. But since 1 is not a 2-digit, it doesn't satisfy. So it doesn't matter what it is. So anyway, it's 1 times something. It's the first pair. The second pair will be 2 times something because we've got a 2. We've got a 2 over here. And next one, 3 times something. And we do not have a 4 because it's only 1, 2. So we skip 4. And the next one will be 5 times something. And then is there 6? Yes, because we've got a 2 and 3. So the next one is 6 times something. And then 7 times something. We do not have a 8. But we have a 9 here, so it's 9 times something. And so far, it's 1, 2, 3, 4, 5, 6, 7. We've already listed 7 pairs, and now we need another 5 pairs, okay? Let's start with 10. 10 times, of course, it's 63. Now, it really matters, so I will write the full expression out because I want to make sure that the other number is also a 2-digit number, or if it isn't, then I would not count it. So it is 10 times 63, and the next number would be 12 doesn't work, so the next one will be 14 because we've got 2 and we've got 2 and 7, so it would be 14. 14 times, okay, the rest is 5 times 9, that is 45, which is good. Okay, the next one is 15 because we've got 5 and 3. So the rest would be 2, 3, 7, that is 42, which is also good. And 16, no. 17, no. 18, yes, we've got 18 because we have 2 and 9. So it is 18. And then it is, it's 35. Here we go. And let's see if we have any more. 19, of course not. 20, not. 21, yes, 3, 7, 21. 21 times, it's a 2, 5, 3, it is 30 here. Okay, good. now we don't have to move on because we have already got the total 12 pairs. Okay, we've got the number has got 24 different factors, so it's not a square number. So in total there are 12 pairs, and now we've got all of them, so we don't have to do any more. And we count 1, 2, 3, 4, 5. We've got five pairs that satisfy what the problem says. So the answer is 5. Okay, it's choice D. Choice D. Five different pairs out there. Okay, this is problem 18. We've done, and the next one is problem 21. It's a relatively easy one. It's a geometry problem. We've got a circle. Basically, the problem says that we've got a circle and the radius is 87. The radius is 87, and this is the center of the circle. We've got two radiuses, and here we've got a right triangle and connect this one. And we know that n is 63. This is n, by the way. Okay, this is n, this is O, of course, and this is P. Okay, this is 63. R is 87, so this is 87, and this is 87. OP is 87 as well. And we are looking for the area of PMN. Okay, we are looking for the area of PMN, which is the big right triangle. So basically, we just need to find out ON. Once ON is found, we can find Pn, and Pn times Mn divided by 2. That's it. So what is ON? Just to use the Pythagorean theorem. But here it's a bit technical. I mean, doing the calculation. This is what we're looking for. ON, the length of ON is this. Now we have to do this. The difference of a square can be computed this way, minus and plus, and be very careful here. We've got 150, and the second one is something 24. Okay, and do not dive into any hard calculation. Just split furthermore. 150, that is there any perfect square? Yes, we do have 25, and 25 times 6 and 6 times 24, which would give 25 times 144. So that is 5 times 12, which is easily 60. Okay, so found ON is 60. Good. Now finally, the area of PMN would be 63 times, this is 60, okay, this is a 63 over here, and we've got 60 and 87, which is 147, and all we need to compute is this, and this is something ugly, but there's nothing else we can do, so just do it top-down way. Long multiplication, 121, kind of a slow, but anyway, okay, 441, yeah. Okay, the next one is it's basically twice that, so just copy the number. Here is 16 or something. Okay, this is a 9261. So this number, this one would be 9261 and divided by 2, which gives 46, and that is 30.5. 4,630.5, and which is okay, choice C. D. It's D. Dog. D. Okay, 4,630 and 0.5. Okay, that's all for problem 21. Not a hard one, just that you will need to use this technique when doing the calculation. Otherwise, you will have to do with something quite ugly and waste a bit time. Still, you will end up with the right result. Okay, this is all for problem 21, and the next one, problem 22, is not hard either. I would say it's a pretty easy one. Okay, let me tell you. The problem looks long, but basically it tells that there's one person. It took this person like 2 hours and 30 minutes. 2 hours and 30 minutes to travel to Kano and to her camp, and the distance is 4.5 kilometers. So this duration to cover this distance, okay? And when it's pedaling all the way back, the return trip, and it's only a third of the time. So it is this duration divided by 3 in this time. And the distance, of course, is still the same because it's just a return trip along the same route. So it's another 4.5. And all we need to find out is the average speed. That is, I would say average speed is, I would say it's the total distance covered divided by the total time costed. Okay, then what is the total distance? Easily 9 km. Okay, what is the total time? Okay, it is 2.5 hours plus 2.5 hours, but this time divided by 3. Okay, and then let's do some calculation here. 9 km, it is 2.5 plus it is 1/3, so in total times in total it is 4/3. Okay, that's it. So here's our, and upside down rule, so that 3 can go on top. It is 27 km on top, and below it is 2.5 times 4, which gives a nice number. It is 10 hours, and finally it is 2.7 km per hour. This is the average speed, which matches choice E, the last one. 2.7 is the answer for problem number 22. Okay, we are doing pretty well here. And finally, we are going to problem number 23, just the next one. Okay, in this problem, we have 2 cylinders. Cylinder A has a radius of 6 and the height of 50. Okay, radius of 6 and a height of 50. The unit is centimeter. Okay. Anyway, I'll just write it down here, but it doesn't quite matter. And we've got cylinder B, which has a radius of 8 cm and height of 50 again. So they are the same tool, but the one is just a fatter. Another 50 cm, and here we've got 8 cm here, 8 cm. Okay, that's everything. And at the very beginning, the second one, the fat one, is full of water, and the thin one is totally empty. And you would pour some water from the fat one into the thin one, so that both cylinders have the same height of water. Okay, they do not have exactly the same amount of water. The volume might be different, but they do have the same height of water, and we just need to look out. We just to find out that height of water. How high is that after you pouring some water from one to the other? And actually, it's not hard at all. Just to find out the total volume of water. And that would be something like the base area would be pi times h squared. This is the base area, and times the height, which is 50, because the second cylinder, the fat one, was full at the very beginning. So this is the total volume of water. And finally, we've got 2 cylinders, but they have the same height. Let's say the height is h. Okay, so it would also be the first, the base area of the first one is pi times 6 squared times h, plus the second one, the same h. So this is now the water in the thin cylinder after pouring, and this is the amount of water in the fat cylinder after pouring. Okay, and here we've got an equation, and we would solve it for h, and of course pi can be removed at once. So we've got a squared times 50 is 6 squared plus a squared, and h. Okay, distributive property, so we just write 1h here. And okay, let's go all the way up here to to make the best use of the space on the paper. So here we've got quite a lot of things. A squared times 50 divided by 6 squared plus a squared, and this is the final answer. Let's have a look at here. This is a squared times 50, which would be 64 times 50. And the below, you will know it is a 10 because it's the 3, 4, 5 right triangle. So it is 10 square. And okay, do some reduction here. 10 square is 100. So it's just like 64 over 2, it's 100, so it reduced to 64 over 2. That would make it a 32. So 32 is the answer, 32.0 cm, which is choice C. Okay, so the answer is 32. Okay, that's it for problem number 23. And we have 3 more problems to be discussed in the next episode. So see you then. Bye.